Step 9, plug holing check. Now earlier we covered the principles of how many exhaust points are required, and this was based on the total mass flow rate of the smoke divided by the size or capacity of the exhaust points. If it was natural ventilation, the stagnation check had to be carried out. But now there's one more factor that must be considered. The number of exhaust points within the reservoir is important, since for any specified layer depth there is a maximum rate, which is referred to as M crit, at which smoky gases can be allowed to enter any individual exhaust point. Any further increase in the rate of exhaust through that exhaust point will serve to draw air into the orifice from below the smoke layer, and this air will be in the form of a vortex, and this effect is often referred to as plug holing. Plug holing is the effect where air beneath the smoke layer is drawn up into the flow through the ventilator by a vortex that develops below the ventilator. This is likely to happen where the depth of smoke is not great or where the ventilators are particularly large. If the effect has been ignored when calculating the necessary fan capacity or the necessary total area of natural ventilators, then it follows that plug holing at the design fire condition will represent a failure of the system, as ventilators will not be exhausting the full amount of smoky gases required. Some of their capacity will be used for extracting clean air. It follows that for efficient exhaust, the number of exhaust points must be chosen to ensure that no air is drawn up in this way. There's no model for quantifying the effect that plug holing has on the amount of smoke that is exhausted via the ventilator, so the only practical way to deal with it is to ensure that plug holing does not happen. There are two basic models that are used to check whether or not plug holing is likely to occur, and they depend upon whether the ventilators are close to the edge of the reservoir or further away from the edge of the reservoir.